this lectures on electronics and optics. Here I'm going to demonstrate you how can you import a third-party BJT model into the LTspice module. Many times you have seen or you are going to see in this lecture series of audio amplifier that we may need some transistors or some devices that are not listed within the default list of the LTspice, and for that we need to import them from third party. So here I'm going to show you how you can. Not only that, when you are importing a third-party model, you need to assign a symbol to that particular model in order to use that model within your schematic. You can do this thing using two ways. Either you can design your own symbol, or you can assign an existing symbol to your particular model that you have imported. How can you design your own symbol and you can assign to your imported model? For that, I already made a video and the link is given in the description box, or you can click on the card to directly go into the video. But here I'm going to show you how you can import a third-party BJT model and how you can assign an existing symbol to your imported model, because many times you may find that directly LTspice models are not available. If you have the LTspice model with you, maybe the symbol files will be associated with you. You can directly use that. But if the LTspice model is not available, Spice model you can download to use for your purpose, and Spice model works fine with your LTspice platform. But for that, you may not find that the symbol file is available with your Spice model. So for that, you need to assign the existing model or existing symbol to your Spice model. And that's the thing I'm going to show you over here. So I think this video is going to be very much helpful and informative, especially for the beginners. So please like, share and subscribe and stay tuned till the end. For this demonstration, I am going to import one NPN transistor and one Pnp transistor. The NPN transistor that I am going to import is 2SC5198 and the Pnp transistor is 2SA1943. Now, why specifically these two transistors? Because these are the power transistor, and in my next video, you are going to see that I will design the output stage for my audio amplifier using these two power transistors. And the output stage is basically a class AB amplifier that delivers a significant amount of power to your output speaker, so that the speaker can vibrate its membrane according to the input signal, because the input signal itself cannot carry the significant amount of power. So that's why we need to design an output stage that delivers significant amount of power. For that, you have to wait for my next video, and here I'm going to show you how can we import these two transistors from Toshiba Semiconductor, because the manufacturer of these two transistors are Toshiba. So let's see. You just need to Google for these two transistors. First of all, I'm going to search the 2SC5198 transistor LTspice model. Okay, and as you can see that 2SC5198 from Toshiba Semiconductor, I'm gonna get that thing. And look at here, you can see that this first one is a data and data sheets. So I'm going to import this LTspice model and just look for the LTspice model. So there is no LTspice model, I think, because if it would be, then it should appear just immediately after the LTspice model, the PSpice model. So here the PSpice model is available, and I'm going to import this one. So here, just click over there, agree and download. As you can see over here that the zip file is downloaded, and here I'm going to extract in this folder, and basically you have to extract the Spice model within the same folder where you are saving your LTspice project. So here I'm going to save my LTspice project over here also, and look at here, this is a PSpice model, and here .lib file, this is basically contains the information regarding the device. This is basically your model file, and unfortunately the symbol file is absent because it is a Spice model. So if it would be the LTspice model, probably the symbol file will be there. But since the symbol file is absent, I need to assign the existing symbol with this particular model. So let's see how I can do that. So first of all, I need to import the NPN transistor. This is the generic one, the default for the LTspice symbol. Now I'm going to press Control and right click. So here you can see that this open symbol and click over there. Now look at here, this is the model that I have opened, the existing model, the default model, and if you click over there, you can see that base is labeled as B, and this collector is labeled as C, and emitter is labeled as E. But the model that you have imported there, it is not necessary that the same level should be maintained. So for that, I'm going to open this lib file using, say, open with and notepad. Now as you can see that pin number 1 is collector, 2 is base, and 3 is emitter. And look at over here, this is the definition for the sub-circuit. So in the sub-circuit definition, the name is 2SC5198, that is the transistor I'm going to import, and here I'm going to assign my existing symbol where this pin number 1 that is mentioned over here, that is the collector. So directly go to over there and rename that as 1, and 2 is for base, so according to that rename that 2 as 2, and 3 for emitter. So here 3, replace E by 3. And next one is you need to replace this NPN, because the name of this transistor is 2SC5198. Just copy from there and right click and replace NPN. Another thing you need to do, you need to change this instance name, because this is the default instance name from the LTspice, and I need to change this one because right now I'm going to use the user defined instance name. So for that, just go to that edit attributes, and there you need to change it by X. Okay, and the next one is the model file, and the model file I'm gonna use this one, 2SC5198. So just copying this one, and here I'm replacing as 2SC5198.lib. This extension you have to provide it over there. As my current project is going to be saved at the same in the same directory, so I do not need to include the path name. But if you are thinking that you are saving your LTspice project in different folder and the model files in another folder, then you have to include the entire full path name followed by the model file name dot the library file name over there. Okay, so now it's done. As you can see right now, the instance name is changed to UNNN, and that is the user defined instance name. Okay, now I'm gonna save this one. Look at here, the symbol name, the default symbol name is available over here, that is the NPN, and that is obvious because I have taken the existing symbol, and right now I'm gonna save this one using this name, this 2SC5198. So I'm copying this one, save as. Look at here, the symbol by default when you are going to save any symbol, so by default directory will be the symbol directory. Here I'm going to this library under symbol, so I'm going to save this one, so 2SC5198. Okay, save. Now let's see if I delete this and if I go in this component list, and if I search 2SC5198, look at here, it is already available within the list of your devices. So I'm going to place it over there. Now you need to check whether this device is working fine or not. So I need to place a ground. Simple, any simulation you can do, and I'm gonna take a battery for that. So that is, say, 10 volt. Okay, and here I'm going to place the ground. I swear I don't know what is this design, but these connections I made only to check whether my device that I have imported is working fine or not, because any type of simulation you can do, the most simplest simulation is a DC operating pointer that I'm going to run for this particular device or for this particular combination, and if it works fine, so I should not get any error. So let's start this simulation. Unknown subcircuit called in this, so this one is the error. Okay, So let's check the symbol once again. Edit, attributes. Okay, so I did the mistake over here. So here I need to paste it in front of this model file, because obviously this one is a model file and I put it over this descriptions. Okay, I hope now this will work. Yeah, absolutely fine. So our NPN transistor is working fine. Now I'm going to show you using the PNP transistors. Then that one is the 2SA1943. Go to the Google and 2SA1943. LTspice. Let's check whether the LTspice is available. Yes, LTspice model is available for this particular device. So I'm gonna get this one. Okay. So agree, download. Okay, so 2SA1943, this LTspice model is downloaded, and now I'm gonna extract it over there via, and bingo, what I got, look at over here, I got the symbol file. Okay, but there's a problem is that already I set the symbol file for the NPN transistor to a C5198, the existing symbol file that I have assigned to them. But here, that symbol file, if I open it, so look at it, this is the symbol file that is associated with the 1943 that I have imported. And if I take the PNP, because this one is the PNP transistor, and if I right click and open symbol, so I can see that this dimension of these two transistors, the PNP transistor, the default PNP transistor symbol, and that one that I have imported, the dimensions, they are not matching exactly equal to them. And why that is the problem? Basically, in design perspective, there is no problem. But when actually you are designing the NPN transistor that I'm going to use in my next video, that is 2SC5198, and that has the dimension different from that on that is the that I'm going to assign for the PNP transistor, because the PNP transistor has its default symbol. So that may looks like a bit weird. So that's why I'm going to use, or I'm going to assign the existing PNP symbol to the imported PNP model. So how can I do that? So for that, it's very easier, because here if I click it over here, look at here, the base is named as 1, and this collector is named as 2, and obviously the emitter will be named as 3. So now I'm gonna change this one. So base 1, so base, I'm gonna place it 1, collector 2 is collector 2, and this one is 3. And this PNP transistor, this name I'm gonna change with this 2SA1943. So this one should be changed to 2SA1943, and the next one is this instance name, that the thing I need to change from this edit attribute, and here just replace QP by X, and that will indicate that this symbol is right now going to be used as an user-defined interface or user-defined symbol. Okay, so in this description it's fine. So the model file that I'm gonna change this one as this mod file. Look at here, this is the model file, and the extension is mod.mod. So obviously this will be .mod. Okay, now this one I'm gonna save. Oh, before that PNP transistor, I need to save it. That symbol I need to save it, and I'll save it in a same symbol directory of the LTspice. So saved, and I'm gonna use that particular PNP transistor, that is 2SA1943. It is available in the default list. So I'm gonna place it over here, and the same type of connections if I do. Well, now I'm gonna run this one as, let's see. Okay, another error. Couldn't open the library file this .mod. So probably that is due to this file location. Let's copy this one and I'm gonna save this file into the location where LTspice is saving its own model file. Okay, let's check. And here within the same folder where the symbol is saved, within the symbol folder under the LTspice library symbol, and as you can see 2SU1 and 43, this is the symbol file and this one is the model file. So here I have saved this model file, and I hope now the simulation should work. Yes, the device is working fine. So anyway, I hope you have enjoyed a lot, and in following this process, you can import any third-party devices or the model, and in a similar way, you can assign your own symbol as well as the existing symbol of the LTspice. So if you find this video is helpful for you, please like, share, and subscribe, and please wait for my next video where I'm going to show you how we can design the class AB output stage for the audio amplifier, where the output stage will power up the speaker by providing significant amount of power. So till then, thank you very much. Thank you for being with me.